or provitamin of microalgae to the milk, because many children, they have the vitamin A deficiency. And astaxanthin is in the form of the capsule. Omega-3 is another our product. And this category of the product identified regarding the need of the Sustainable Health Institute. Just a view of microalgae. They can cultivate it in different area because they are extremophile organism. They are the living organism from 3.5 billion years ago, and they are responsible for the production of 80% of oxygen in the atmosphere. The research on microalgae began 60 years ago that NASA, they are established a laboratory and they are tested. They are planning to using this microalgae for the production of atmosphere in another planet, especially in the Mars. And then they are identified their quality and vitamin, amino acid, and they are using as superfood for the space, the space scientists that they are using the shuttle to go to the Mars or to the laboratory, space laboratory. This is just an ingredient existed in the microalgae. You can see it's very rich, some of them to amino acid, about 65%. Fat, mostly is non-saturated oil or fat, vitamin, mineral, and carbohydrate. This is our product. We can produce in the tablet form or capsule or the powder that added to the food, microalgae food, into the different kind of food, to salad, to macaroni, chips. And this is the antioxidant, provitamin A, and astaxanthin that is, we are making oily formulation and for pack in soft gel. And this is just a view of this kind of antioxidant in the nature. Existed in many of living organisms on the Earth planet to protect their DNA on the irradiation of UV. They are eat this kind of microalgae, and you can see the pigment concentrated on the bodies of this flamingo. Another line that we are developing this technology, we are using the antioxidant, the pigment of the microalgae for production of sunscreen and skin care for the prevention of skin cancer. This is the process of the product. Should be selected the best strain. The nutrition that we are added to the seawater is fertilizer, nitrogen and phosphorus. And we need the sunlight, seawater, carbon dioxide. You can cultivate it in open or closed system, and the biomass transferred to the biorefinery for the processing. This is the coastline of Persian Gulf and Oman Sea in Iran. We are site selected because we cannot cultivate it any place close to the sea. Should we have the clean water, should we have the enough land, and should be available the CO2. So we are site selected, and we are choice for site. One in Bushehr is Persian Gulf Knowledge Village. Second is Qeshmailand in Jask and in Chabahar. And of course, if you like it to develop this technology, should be doing same procedure for screening and identification the microalgae from the coastline of the Oman, because they are adapted to the environment condition, and should be selected the site for the establishment of the site for the biofuel production. This is the Qeshmailand that selected now for the establishment this biorefinery, and we need some information about the temperature, about the raining time, and about the evaporation of the water. This is for 10 years record of the environmental condition in the coastline of the Persian Gulf and Qeshmailand. And you can see there is a short time for the raining because there is the open pond. If you have many raining during the year, they can contaminate it, they can reduce the salinity and change the condition for the cultivation of microalgae. But normally, south part of Iran is only in the best condition, less than 150 milliliter of raining, and his rain only is during the September, November, not more. And the rest of the year, we can cultivate it continuously for 300 days of microalgae in the biorefinery. We are using the flue gas directly from the gas generator for the production of electricity. There is not any processing for the transfer of flue gas to the open pond. Just should be reduce the temperature because it's hot to around 100 to 200 centigrade. And we are using the coil of the seawater to reduce the temperature, and directly we are transported the flue gas by diffuser to the open pond. The open pond is designed in the module of 100 hectares. And the expansion of the technology will be 1,000 hectares. This is the open pond design. Is 3,000 meter is the surface, and the deep is 25 centimeter. The cultivation area is covered by PVC to transfer best condition of sunshine and sunlight to the open pond. And the biomass, as I mentioned, we are produced continuously during 300 days per year. After peak of the biomass, every day between 20 to 30% of the volume, they are separated. We are recycle the water and return to the open pond, and the biomass, because the microalgae that I'm isolated is a autofluctuant microalgae. We don't need the centrifuge for sedimentation of the biomass. After 3 hours, when we are transferred to the collection ton, they can sediment it, and directly we are transferred to the high pressure homogenizer. They are disrupted the cell, and by gravity, oil, water, and rest of the biomass was separated. The biomass residue can be used as directly as a feed additive, biofertilizer, or we can extract it, the compound that is high value additive. And the second line that we are established is because most of the microalgae, the rest of the biomass contain of starch. So we can use the amylase enzyme and produce the simple sugar, and by fermentation produce the ethanol. So it's the most high capacity of the biomass for the ethanol production. For the lignocelluloses, we have the problem of the lignin, and for the breakdown of the cellulose is necessary the high temperature acid using, and also the enzyme. But this is a simple biomass, and 40% of the rest of biomass contain of starch directly can be converted to sugar and by fermentation to ethanol. We are designed the project for the production of by 2 ways of conversion of oil for the biojet, and also it is possible to convert it to biodiesel. We are using the biojet because regarding the emission trading scheme, this is a law of Parliament of European country. From 2012, all the airlines that they are flight on the European country should be paid 15% of the CO2, the tax. And if they are not paid this tax, they should be paid for 1 ton CO2, 100 euro the penalty. And they are estimated around 4 billion euro existed of the market for the biofuel. And many companies, they are approached to produce this biojet or biofuel. Estimation of the biofuel globally in 2070 is 81 billion US dollar. This is the procedure of our work and the design that we are transferred to the know-how to a private sector. Is a consortium of gas and oil holding, 16, that they are invested for our know-how, around 1 billion US dollar in 1,000 hectares. And the oil, when separated, is a crude green oil, about 50 to 60% of the lipid, and can be converted to by esterification to the biodiesel or to petroleum refinery that is existed for the hydrotreating. And regarding the carbon chain, can convert it to jet fuel, to high quality diesel, and to the gasoline. For the biojet, this is the possibility existed to convert it to the jet fuel, is the camelina, oily seed cultivated in the north of Europe. There is microalgae, and there is the jatropha. But the product of the jatropha they have the difficulty because there is some toxic material in the oil and should be separated, so it's very expensive processing. For the camelina, it's very limited area that this kind of the plant grows, so the most easily, especially for the north of Africa and in the Middle East, is microalgae for conversion to the biofuel and to the different kind of biofuel. The process of hydrotreating existed is more than 100 years in the refinery. The temperature is 400, and they are using the hydrogen, high pressure hydrogen, and they can convert it, the oil, the crude oil, to the jet fuel or gasoline or diesel. For microalgae, we don't need this high pressure, and this temperature is only 250 degrees centigrade the temperature. The hydrogen is 50 bar that we are using. The byproduct is different kind of the fuel and fresh water. This is the procedure of hydrotreating, and in Iran, in 4 refineries, this station existed. And this is the area, the station that during 10 years ago, they are producing the gasoline with the many problems. So it's free now, and we are, this company choice Qeshmailan because it's very close to the Bandar Abbas refinery. So the crude oil, they can transport it to the Bandar Abbas refinery and treat it, hydrotreating to produce the fuel. This is the capacity of our product with this kind of microorganism. 240 tons is the biomass productivity per hectares. 50% is the oil, and as I mentioned in our microalgae, 40% existed of starch that they can produce 41 ton of ethanol, and with cultivation of this 1 hectare of microalgae, we can sequestrate 400 ton of CO2, and the rest of the biomass is 48 tons per hectare, and we can use as feed additive or biofertilizer. And this is just announcement of Qابوس that announced that Iranian Research Organization for Science and Technology set up a biofuel platform for microalgae, and they are approached to the Qatar to establish a plan for the biojet production. Is the Qابوس and petrochemical company of Qatar, and they are invested $3 billion US. but they are in the laboratory. The technology is not developed. And Boeing also focus on high productivity and sustainable biofuel. You can compare the soybean, salicornia, camelina, jatropha, and algae. The productivity is completely different, and with all the company now, they are focused on algae because it's a sustainable and they can produce enough source. This is just perspective of establishment of the project, and thank you for your attention. If you are interested, there is a short film about our cultivation of microalgae. Do you like to see it? If there is time, if not.
Yeah, the problem is I already gave you like 5 minutes more than the time allocated for your seminar. So
how big is
how long is the film?
Sorry?
How long is the film?
The film?
Yeah.
2 minutes.
2 minutes? I think, yeah, go ahead with it.
This is a film in our pilot plant. For the cultivation of microalgae, it's necessary to cultivate it in a small quantity, and step by step, you can add the capacity to the large open pond that you are seeing in my presentation, the 3,000 hectares. We cannot going from laboratory directly to the big open pond. So it's the different photobioreactor for the cultivation of microalgae, the column photobioreactor. This is 200-liter photobioreactor that we are optimize the microalgae that we are isolated from the sea, and then you can cultivate it in large scale. And this is the open pond, 25,000 liter. This is 2,000 liter, the pre-culture of the big one. With a paddle well, you can mix the media because of the circulation of the water. You can distribute the nutrient, you can distribute it, you can exchange of the gas, and also the microalgae can be have enough irradiation of the sunshine. This is in direct sunshine cultivation. 25,000 liter is the capacity, and 11 open pond, photobioreactor, flat photobioreactor, different kind of reactor existed. And 4 new project is under study in microalgae. One is calcitonin. We are clone in microalgae. We are establishing a platform for cultivation of recombinant protein. The second project is a joint collaboration with Ruyan, a nervous growth factor clone in the microalgae. The third one is a joint collaboration with Pasteur Institute on a national project for the vaccine of malaria. One molecule, one antigen of Plasmodium falciparum, another one from Vivax's clone to the microalgae. And the fourth is production of papillomavirus, that is the main cause of cancer of uterus, cloning in the microalgae for the production of the vaccine. This is the project under study. The 2 package that I introduced is the know-how is designed and is transferred to the consortium for the large scale for 1,000 hectare cultivation. I welcome all of your group, your scientists, for the training if they are interested to working on microalgae. But as I mentioned, for the biofuel, if you are interested to produce in Oman, should be isolated the microalgae from the coastline of Oman, site selected for the selection of the area for establishment of the cultivation. It is necessary to analyze the water, should be clean, should not be contaminated, especially if you want to produce the pharmaceutical, nutraceutical, the anti-aging product. This is just a model establishment, the first step that we are established, the open pond. And then dependent to the program that you have for the production of kind of the fuel, the processing should be established for the esterification production of biodiesel, and for the biodiesel you can add it 50% to all the engine of the car is not necessary for any change. Yeah. But more than this should be adapted the engine to the biodiesel.
Okay, thank you.
Or transfer to the refinery and produce the different kind of other fuel.
Thank you, Professor Muazzami, for the
thank you.
For the very interesting presentation. I wish we have the time to see the whole film, but due to limitation in time, we have to cut it here. And small door all is open for questions, maybe 2 questions. Yeah, please, Dr. Alamia, go ahead.
Thank you very much, Prof, for the very interesting presentation. And I'd also like to congratulate you for pioneering this work in the region, because as far as I know, there isn't no region in the Middle East that is that advanced in the production of biofuel, so congratulations to that. My question is regarding the strains that you're using in the open ponds. You mentioned the titers in the productivity slide. My question is, are you using native strains, or are they genetically engineered to increase the oil content? And if they are the native strains, then what is the percentage of the lipid content in that strain?
Yeah. This is the wild type. We are not using the genetic engineering, especially when you are working in the environment, in the open pond, and if there is not the system closed. So it's the wild type, and the wild type, they can adapt it to the condition of open pond. You cannot genetically engineer organism cultivated in open pond, in the seawater, in the sunshine directly. So should be isolated the wild type, and the wild type, you can see, is produce the large quantity of the oil. Is not necessary to change it. And with the genetic engineering, because you are change the photosynthetic pathway, you can reduce the product. You cannot add the product, especially for this kind of the technology.
So what is the percentage of the lipid content in the strains? Because normally it's about 40% for it to be economical, right? If it's just produced 20% lipid content, then it's not really worth extracting and harvesting, and the cost would be massive.
Yeah, you should be isolated the microalgae first, the pure culture, and a screening for first high productivity, because you can go into the larger scale, so should be produce the high quantity of biomass, and then a screen for the high quantity of the oil. And then by the standard that I mentioned in my presentation, and my presentation is on the computer, if you can use it, should be in the range of the carbon chain between 14 to 22. Perhaps you can isolate the microalgae with more than this quantity of oil, but the carbon chain is not suitable for conversion to the biofuel that you are looking for that.
Thank you very much.
Thank you. Just one more question, please. Go ahead. Yeah.
Thank you, Doctor, for your presentation. It's really quite informative. My simple question is one, that when you add CO2 to open pond system, it reduces pH to great extent.
The system is full computerized. There is a control panel, and controlled by computer, by PLC, perfect. And pH, level of the water, CO2, and biomass was monitored. And all of the open pond, they have a separate control system, and the whole pilot another control system. And if you look to the surface of the open pond, we are using different kind of polymer to covering the open pond, because should not make problem for the cultivation, should not attach the microalgae, should not sediment it. and also different kind of paddle well. The structure, the model, and the structure, chemically structure.
Yes.
We are using the PVC, we are using
Yes.
the aluminum, and we are using the stainless steel. So, and this is a flat photobioreactor. For the cultivation in big open pond, we are using the exhaust of a steam generator. And for the open pond and this kind of cultivation system, the flat photobioreactor is the capsule of CO2 that is added, the CO2 to the
First CO2 is
system.
added to the nutrient media, and then subsequently that nutrient media is added to the water.
Yes, yes.
Right,
If you are added, this is a flat photobioreactor. If you are added the CO2, the efficiency of photosynthesis increased to four times more. So you could have the high productivity of the biomass.
But in my experiments, what I have found that by directly adding the flue gas,
Directly, I say even for the biogas, for the flue gas, we are added directly. We are by a diffuser. We are diffused in the open pond. Should be only the temperature reduced to around 70 degrees.
perfect. So we are
Yes.
only reducing the temperature, but
Yes,
not,
but only for the gas generator.
Okay.
If you are using the oil or gas oil or diesel, should be filtered because there is
should be
the
filtered because it has many other
contamination.
components as
Yeah.
well.
Yeah.
And the
Hello, excuse me.
microalgae, they are used the NOx and SOx as a source of the nutrient.
Okay. Thank you.
So these are
Yeah, thank you so much, Professor Muazzami, again, for the very informative presentation. And the last seminar in today's program will be given by the star, Dr. Hani Al-Qadi from Sultan Qابوس University College of Medicine. He will conclude and summarize the outcomes of the medical session we had in the morning.
Thank you very much, Dr. Yahya, for calling me a star. I like the title. So we reached to the conclusion of this symposium, and my talk is going to be basically just a summary of the ways that we can collaborate in the medical field with our brothers and sisters from Iran. I'll just start by, reiterating the fact that we are very pleased to have such an esteemed delegation to come and visit us in Oman. It's such an honor, and we really appreciate your presence with us here. And I hope your trip was worth the effort. So I looked into the different topics that we have discussed in the seminar, and the main things that we are looking into collaborating with Iran is in the medical field. First of all, organ transplantation. It is something that is taking a priority in our future planning in the university. Kidney transplantation is discussed today, but we're also looking into further collaboration in terms of liver transplantation and other organs. Infertility and with all its fields, stem cell research, nursing, and student exchange. So in organ transplantations, as I said, kidney transplantation, liver transplantation, heart and lung transplantation, and I had the honor to meet the surgeons who are doing the cardiac transplantation in Baqiyatullah Hospital in Tehran, and the results that they're achieving is actually very, very impressive, and I hope that we can copy such success to Oman. the ways that we're trying to cooperate with Iran is, first of all, is faculty exchange. We would appreciate that the experts can come to Oman, and they're welcome at any time, and we can organize either symposiums, workshops, or actual, surgeries that can be broadcasted to the whole of the country or abroad even. Nursing as well takes priority here, and we are looking into sending our nurses to train for short courses with the, we've seen the nurses in Iran and the nursing schools there, and they're very, very advanced. So whether it's exchange or training, we would for sure benefit, and also Iran will benefit from such an experience. Now, in terms of infertility, we're also looking into collaboration with the Royal Institute in terms of either staff training, sending our staff to the Royal Institute where they can get trained. We looked at the facilities there, and again, it was very impressive. Conducting joint workshops and seminars are also on the cards. Stem cell research is also one of the priorities that we are looking into. We have already ventured into this, and we want to go further in that field. Now, in terms of training of nurses and recruitment, there has already been recruitment of nurses from Iran to Oman, and the experience was a success, and we hope that we can build on that experience further. We do need nurses from different backgrounds, and that is beneficial to our nurses as well as to the patients and the doctors. Training of our nurses also in specialized centers like transplantation and infertility setups is also appreciated, in addition to research. And finally, I'd like to mention a few words about medical students exchange. I happen to be also the coordinator of medical students electives at the College of Medicine. So we do receive yearly medical students from all over the world, up to 15 students per year. And it's usually a very successful experience for them. Some of them actually ask to extend their elective by 1 or 2 months. And it is a pleasant experience overall. The good things is what we are, at an advantage for is that, first of all, we don't have any limited number of students. We can accept any number. We would do the arrangements for the visa from the university. The accommodation is provided with a very small fee per month. I think it's about 100 riyals per month, or 120. That would include 3 meals per day and free transportation back and forth to the hospital from the residence. In addition to the leisure activities, we hook them up with our own medical students where they can, they take care of them, they show them around. And so in addition to the scientific experience, it's also a very cultural experience for the medical students. Another thing is that we don't mind any specialty, so whichever specialty your medical students are willing to come and train at, it's available. And this is one of the advantages of the university hospital, that we have a lot of specialties in the same hospital, and it's not present anywhere else in Sultanate of Oman. And finally, the training here, the students are in direct contact with the consultants. And from the feedback that we get from the students from Europe is that they don't dare even to talk to the consultant. There's a big gap. And there is hierarchy. That is not there actually here. There is direct contact with the senior trainers. So we welcome your medical students at any time, and please feel free to contact me if you want, and we will facilitate it for sure. At the end, a word of thanks to a lot of people. Actually, I have a long list. I'll start with our guests. Thank you very much again for coming, and it's such an honor to have you here. I would like to thank the government of Iran for welcoming us in Iran and making it a very fruitful and beneficial experience. I'd also like to thank the organizing committee headed by Her Highness Dr. Mona Al Saeed. Thank you very much. The International Cooperation Office, the CET and the SQU, the public relations for facilitating things, the Sultan Qabus University Hospital, the colleges, all the colleges that have participated in the symposium. In addition to that, we would like to also thank the Ministry of Health, the PDO, Petroleum Development of Oman, the Ministry of Oil and Gas, Ministry of Higher Education, Ministry of Agriculture, Ministry of Manpower, in addition to the Colleges of Applied Sciences. All of these institutes have participated in this symposium, and thank you very much. So I would like to invite Her Highness to the stage to give the tokens of appreciation to the participants. So with call your name, please approach the stage. Professor Mehdi Ahadian. Thank you very much. Professor Nasreen Muadami. Professor Abbas Ali Khudadai. Thank you very much. I really appreciate it. Dr. Izzatullah Kazim Zadeh. Did I pronounce it right? Our very dear and very close to us, Professor Shihab Ayatullahi. Special thanks to Professor Shihab because he's the one who organized the trip to Iran and this conference as well. Thank you very much. Thank you. Thank you very much. Dr. Payam Zahidi. Thank you. Dr. Ali Malboubi. Thank you very much. Thank you. Thank you. I really appreciate it. Dr. Masoud Hoshman. Thank you very much. Professor Nasser Simfarouche. Thank you very much. And from the Omani side, Dr. Nabil Lawati. Thank you very much. Dr. Maha Al Khadouri.